Very well, so let's get started. Hello and welcome to this talk about WebAssembly and the question whether WebAssembly is a container killer. This talk is quite special for me. You know, I had been a frequent speaker up until 2.5 years ago. And 2.5 years ago, something we all know happened. COVID happened, right? And in the last 2.5 years, I was only doing virtual conferences. And today is my first real life conference after 2.5 years. So I'm really looking forward to this session. The second thing is this session is very near to my heart. I, personally, am a passionate full-stack developer. I write code on the server, I write code on the client, I do TypeScript development, C# development, Rust development, Go development. So all these technologies are very near to my heart. And something new comes up, or came up in the last few years, and that is WebAssembly that brings all of that together. I personally think that WebAssembly is one of the most exciting new technologies that will shape our lives as full-stack developers massively, or reshape the environment massively over the next years. And this is the reason why I proposed this talk. What can you expect in the next hour? I will tell you a little bit about my conceptual view, how I see WebAssembly. And I would like to focus on WebAssembly outside of the browser. There are many talks in this conference where you see WebAssembly in action inside the browser. You see the Blazor framework, for example, from Microsoft, and there you see C# compiled to WebAssembly running in the browser. We all know that. You have probably seen this demo. But this talk goes beyond the browser. We take a look what WebAssembly can do on the server, what WebAssembly can do as a component system. This is what I'm going to do. This is what I'm going to tell you in the next hour, and then you'll see a lot of code. So we'll dive through a lot of samples, okay? My samples will be in the #1 language for WebAssembly development nowadays, and that is Rust, okay? Don't worry. If you don't know Rust, if you haven't seen Rust code before, we will not dive into any details about the Rust code, okay? So you will definitely understand it, but I have to use Rust because Rust has great support for WebAssembly. C#, for instance, has very limited support for WebAssembly outside of the browser currently. So I couldn't do the demos that I will do in this session with a language like C#. I could do it in C, I could do it in Go, but it happens that I'm a big fan of Rust. I write a lot of code in Rust, and therefore you will get a glimpse of Rust. So let me quickly introduce myself for those of you who don't know me. My name is Stropek. I come from a beautiful town called Leonding near Linz, and this is in Austria. I'm a passionate developer for more than 25, nearly 30 years. I grew up with C++ development, then moved to C# because I fell in love with this language and with the very first technical previews, and I have been using C# all the time. And in the last years, when I did a lot of cloud computing, I also moved to additional languages, especially Go and Rust. And this is what I'm going to show you here in this talk too. I'm an MVP and regional director of Microsoft. That does not mean that I'm on the payroll of Microsoft, not at all. I have my own little company, which is called Software Architects. But regional director and MVPs are a title that you get if you do a lot of community work, like speaking at this conference. Besides my work in my own company, I do a lot of trainings, especially also with a partner of ours, IT Visions. I think Holger is in the audience here. I'm a teacher 1 day a week. I'm a teacher and I'm a mentor. In the community, I'm chairman of the Coding Club Linz, where we run a Coder Dojo, which is a programming club for kids. And yes, some of our kids already do Rust, if you ask that. And I'm also one of the co-founders of the Rust Linz meetup, which, by the way, is very interesting if you want to learn Rust. We do monthly virtual meetups, so you can join us. Just go to Rust Linz AT and you will see our next meetups. And with that, without any further ado, let's dive right into it. When we talk about containers, one of the most important things that should come to your mind is trust. Containers are a possibility to limit the view of code that you run regarding the host system where this code is run. Code that you run inside of container cannot access the entire file system. It cannot access everything on the network. It cannot use as much CPU as it wants. So you don't have full trust in the code. You put it into a container. So what we want as developers, we only want to run code that we really trust. From trusted sources, like trusted suppliers, trusted employees, or open source software where we know that the community who built that code can be trusted. We only run trusted languages inside of our system. The question is, what do we trust? Do we trust code in C? As we all know, C is very, very hard to master. It's very simple to make mistakes if you write code in C. While if you write code in Rust, you get proven memory safety. So languages can do quite a lot to provide security and trust over other languages, which might not that be as trustworthy like C. Not because the developers are bad or they are going rogue or something, they simply make mistakes. And there are large studies from large vendors like Microsoft which prove that C code has a lot of memory issues. All the C code, even C code written by real professional C developers. However, even if you use languages like Rust or managed languages like C#, there can still be security issues. And the question is, can you trust the code? Nowadays, the thing even got more complicated. Because even if you trust open source software, do you really check every single line of every single open source project that you use in your applications? Probably not, right? You're vulnerable to supply chain attacks. Things like that happen all the time nowadays. You trust your employees, your fellow colleagues, right? But can you really trust them? Some of them might go rogue. I don't know why. And the third thing is, people make mistakes. Even in languages like Rust, as I mentioned, write unsafe code in Rust and you get semi or untrusted code. So what we want in modern systems, especially in the cloud, we want to run trusted code, but we also want to impose limits. Let's call them sandboxes. We want to sandbox, limit what code can do. We need to isolate our code. Containers do exactly that. I already mentioned that. But there are other possibilities to limit the blast radius of code that might go rogue. You can put it on separate physical machines. That's quite expensive, right? You can put it on separate virtual machines. That's better, but still quite expensive. You have to patch the VM. You have to update the VM. The VM will not be used frequently, so most of the time the VM will just sit there and being idle. So in that area, containers came up. Containers are much more lightweight. They are virtualization on a different abstraction layer. They virtualize on the level of the operating system. I'm pretty sure that nowadays in 2022, most of you have taken a look at containers and you understand how containers work. If even containers are too heavyweight, you can also isolate code to a certain extent in separate processes. You can spin up a separate process, not a thread, a separate process, and if this process dies for whatever reason, the process will not kill your entire application. So we have already, nowadays, different levels of isolation. And what we want to pretend is code that escapes our sandbox. This is what we want to prevent. Now, let's talk a little bit about efficiency, and we will see that when we talk about efficiency, not just about semi-trusted and untrusted code, WebAssembly will become super interesting. The question is, do we really need a large separate house for every single process, for every single task? You could take your application, split it up into multiple components, and then run a separate virtual server for every component and talk gRPC or RESTful Web APIs or GraphQL between these physical servers. Would you do that? You could set up firewalls between these physical machines. Would you do that? Well, probably not, because it's way too expensive. On the other hand, if we simply run everything in a single process, maybe separated with threads, we only have a single flat, where 10 people living in the same flat, and if one person, I don't know, makes a mess, everybody is kind of unhappy. You know what I mean? So we need something in between. We need to find a balance between isolation and efficiency. Now, the overall topic is we want to make good use of hardware, good use of people's time, and so on. I already told you that we can do sharing on different levels. But containers are already a step into the right direction. Containers make it possible to isolate certain modules, some call them microservices, in their separate environments. And in these environments, you can limit what they can do. But on the other hand, talking between these modules becomes pretty difficult. I once heard the saying that microservices are turning a function call into an adventure. And this really brings it to the point. I could take every single function of my app and put every single function into a separate container and then do a gRPC call instead of a regular C# function call. I could do that. I would be crazy if I would, but I could. Nobody does it. And what's the consequence of that? We run semi and untrusted code inside of our own processes. We are vulnerable against supply chain attacks and things like that. So it's not just security, it's not just isolation, it's also developer productivity and the toil that is needed to keep systems running. We need something that is more lightweight than a VM or a container, but still offers the security, the isolation, and the platform independence that containers give us. We want to be able to write a host application in C# and then host a component in Rust, for instance, inside a sandbox because it's only semi-trusted. Something like that would be really, really great. Now, as I told you, containers are already more efficient than VMs, yes, but they lead to more complex architectures. And in practice, in many cases, you avoid using containers and build monoliths because they are easier to build. I've heard many, many people talking about beautiful monoliths because they don't want to go down the microservices road because they have learned or experienced that microservices lead to a large system overhead. And they are right. They are perfectly right. Now, the third topic that I would like to go in conceptually before we go into the code is cross-platform. How can we make sure that our code runs on many platforms? We want to build code once and run it everywhere. We want to have portable code. And with C#, many of you are C# developers. With C#, we can do exactly that. We can compile code to an immediate language, and this immediate language runs everywhere. We can take our TypeScript code and compile TypeScript to JavaScript, and JavaScript runs everywhere. But if we do ahead-of-time compilation, if we do native compilation, then our code must be compiled for every target platform. We have to compile for Linux. We have to compile for macOS. We have to compile for Windows, 32-bit, 64-bit, and our code is no longer portable. Ideally, we have just-in-time and ahead-of-time compilers available for every platform. But every platform has to bring its own ahead-of-time compiler. If C# wants to support native compilation to Windows and Linux and so on, then it needs its own ahead-of-time compiler. And I think Holger will talk about that in his keynote after this talk. I see him nodding, so make sure to watch Holger's keynote. You will hear about that. Containers, can they help you in that regard? Could containers magically make code cross-platform? No, they can't. Who is using Windows containers? Nobody, right? I don't think so. Linux containers, that's it. You compile to Linux, you run it in a Linux container. You cannot run a Linux container on a Windows server. It doesn't simply run. It doesn't simply work. You need a Windows server to run a Windows container. You need a Linux server to run a Linux container. Everything else, you have a hypervisor in between. That's the thing. Containers are not platform agnostic. That's the point. So, now we heard a lot about VMs, containers. What about WebAssembly? Couldn't we have portability, like we have it in C# with intermediate language, and add efficiency, like not having to spin up a virtual machine for a sandbox? And could we have this sandbox stuff, everything all mixed together? Yes, we can. It's WebAssembly. That's the whole idea of WebAssembly. WebAssembly outside of the browser. You compile, let's talk about what WebAssembly is. You compile your code, be it C#, be it Rust, be it Go, be it C. You compile it not to a machine language for a specific processor architecture. You compile it to WebAssembly. And WebAssembly is a binary format, a binary virtual machine, a stack-based virtual machine, which is way lower than what you know from a Java virtual machine or MSIL, the intermediate language of C#. Many people ask me, why do I need WebAssembly? I mean, I compile C# to IL, and IL is the same as WebAssembly. By far it is not. IL is object-oriented. IL knows interfaces. IL knows reflection. IL knows a garbage collector. So it is on a completely different level of abstraction. If you take a look at IL in Java or in C#, WebAssembly is really very, very low level. There is no garbage collector there. There are no high-level types. There are no object-oriented patterns where you can have inheritance and things like that. Wasm and WebAssembly is very low level. So compiling WebAssembly to the last mile, to the processor when you really run it, is a very simple task, because you're already very near to assembler. Completely different than IL and C#, but still, it's language and platform agnostic. WebAssembly does not say anything about the language that you write your code in. Use C#, use C, use Rust, use Go, use whatever you want, and WebAssembly acts as a compiled target. You take a code, you compile it to the WebAssembly format, and then you can run it inside the WebAssembly runtime. Inside the browser, the WebAssembly runtime is built in. Every modern browser nowadays has WebAssembly built in. Now, what about outside of the browser? Outside of the browser, we need a host. The host can be a custom host, a small little executable that you write. It turns out that many of the hosts that come ready-made, that's the second point, like wasmtime, for instance, are also available as libraries. So what you can do, you can easily write a language, a program in C# or Go or Rust, and simply add a library, and you get the Wasm runtime, including a sandbox and everything what's beautiful about Rust. You get it inside your app. You build a business app, and you want to run some kind of plugins, but in a secure way, put them into a WebAssembly sandbox, and they will work fine. Get the idea? Now, there are ready-made hosts. You don't need to build your own host. I mentioned two of them. wasmtime and Wasmer are two of the most important ones. I will use wasmtime in this talk. The question is, WebAssembly on itself can just operate on memory. How does WebAssembly code interact with the operating system? If it's running in a sandbox, it cannot just do a Linux call. Then it would not run in a sandbox, right? So something needs to define the borders, a platform agnostic API to do operating system level stuff, like accessing the file system, accessing the network, and things like that. And for that, a very important project comes into play. That's WebAssembly Systems Interface, short WAGI. So Wasm plus WAGI is what makes WebAssembly really, really interesting. Because WAGI is a little bit like the container runtime. WASI is a boundary between your code running inside the WebAssembly sandbox and the operating system. And it protects your precious servers from WebAssembly code going rogue. Because it can only access, for instance, those file system parts that you allow it to execute. Sounds like container volume mounts, right? Very similar. So WebAssembly is a little bit like a container image format, the OCI. Okay? WASI is like the kernel API through which a container talks to the Linux server plus Linux namespaces, which prevent your containers to execute things that you don't want it to execute. So remember Wasm plus WASI. Short demo. So I have my notes here. By the way, these slides are available online. Let me quickly show you the link. So if you want to have them, take out your phone. Oops, here we are. Here you have the URI, the URL. If you want to have them, go here. If you can't find them, or if you don't have your phone in your hand and you want to have them later on, just shoot me a Twitter, a direct message. It's Stropek, and I will send you the link, okay? Good. So the slides are there. You do not need to remember what you see here. Good. And the first example that I have for you here is a little bit of Rust code, which is pretty simple. And even if you haven't written Rust ever, you will understand what this thing does, right? It's hello world in Rust. We could easily execute this guy. Let me show you that. We could say cargo run, run bin. Let's do it the other way. It's the level 0, this one, and say cargo run. This is how you run code in Rust. And as you can see here, let me run my zooming tool. Here it is, so I can zoom in a little bit. Here you see, hello world, it's working. This is machine code. It's not WebAssembly yet. However, what I have done is I have written a little just file here. Just is a really nice tool. If you don't know it, that's a trick I can give you. Just is like make, but for 2022. It's really a nice tool. You can just implement very simple scripts here. And I have prepared here the first one. Let's take this one away. Okay. I will zoom in. So if you can't read it from the back, I know that this room is pretty large. If you can't read it, I will zoom in immediately, okay? So I'm going to just say, just run level 0, how was it called? WasmTime. Nothing special. Sorry, that's the wrong one. Where did I, sorry. I execute the wrong one. Just WasmTime, that is what I prepared. I will show you in a second what it does. And you see, we still have hello world, nothing special here. But the most important thing, which you have to understand, is that we now just ran the code inside WebAssembly. So all I did when compiling this Rust code was telling Rust that it shouldn't generate Linux executable. I told it to compile it to WASI. What I get is a .wasm file, as you can see it here. And then I used a ready-made host called wasmtime and executed the wasm file. That's it. And now I can run any code that supports compilation to Wasm inside of wasmtime on any machine that I want. So this is the first step towards portable code. Rust is a native language, not like C#, where we have intermediate language. But with WebAssembly, I have a compile target where I can take my Rust code, my Go code, my C# code with ahead-of-time compilation, put the code into a Wasm file, and run it with wasmtime, Wasmer, or with a few lines of code, and the link is in my slides, in your own application. Completely platform agnostic. WasmTime doesn't care whether you used Rust, Go, C#, C, or whatever, as long as you produced WebAssembly code. Question?
Can I use this Wasm executable on different machines?
Yes.
Windows,
Yes.
Linux?
Yes. It's available everywhere. Yes.
I can take it and run it.
You see, the wasmtime, the application itself, it has to be the executable. So there is wasmtime for Linux, wasmtime for Windows, wasmtime for Mac, AMD, I don't know what. Wasmtime is available everywhere. Okay. You need a runtime. You need a WebAssembly runtime. But wasmtime is available for you. And it's also available as a library, as I told you. So you can take wasmtime and put it into your app, and then your app becomes the host. Okay?
Thank you.
Good. So this was the first sample. Let's continue. Why not? Why not building a web server with WebAssembly? And let's have a crazy idea, right? Whenever we get an HTTP request, let's just run a separate executable inside Wasm. Let's run a separate process as an HTTP handler and pass in the HTTP requests over some standard. We will see how that goes. And with that, we would suddenly get a web server where we can write web handler in any language that supports WebAssembly. Enter WAGI, WebAssembly Gateway Interface. For those in the audience who are as old as I am, you might know CGI, Common Gateway Interface. Anybody? Pretty old, right? Okay, you raised your head. We have both gray hairs, so we are old enough. We know CGI. You know what the idea of CGI is? The web server takes the HTTP request in. Then it starts for each request a separate process and passes in the HTTP body through standard in, the HTTP header through environment variables, the query string through command line arguments, and you write the HTTP response using standard out. Isn't that crazy? Yeah, that is really done, and it has been done, and is back. Isn't that beautiful? That's the idea of WAGI, and with that, I want to show you some WAGI demos. But hey, don't run away. If you don't like this architecture, it's just a bridging technology to something way cooler that will come immediately afterwards. But it's important for us to understand this thinking of how WAGI does its magic so that we can understand what the next level is, okay? Good. Now, let me show you the next example. The next example is now a web server written in Rust. Make yourself prepare yourself to seeing really complicated Rust stuff because we want to build a web server, right? Bang, here it is. See? Do you see this magical web API framework that I use? Let me show you the name. That's the beauty of WAGI. There is no framework. All you need to do is you need to print something on standard out. And that's it. That is how you create a web request handler, right? And then you put WAGI in the middle. WAGI is built on wasmtime. So WAGI just runs your code compiled to WebAssembly in a separate sandbox. And this code can do exactly what we allow it to do. Let me show you how that works. Okay? Let me see my notes. Okay? The first thing is what I do is I say just run native. Now this just run native level 1, this will run the application compiled to machine language, and you see what's going on. It's just printing something on standard out, right? That's it. That's not a web server yet. So let's turn it into a web server. If we want to turn it into a web server, the only thing that we need to change is instead of just running the app, we run WAGI. WAGI is WebAssembly, is a WebAssembly host, let's put it that way, and it's configured using a TOML file. That's it. Now this TOML file looks like that. I want to raise your attention here, okay? This TOML file just says, hey, if something comes in through the URL level 1 ping, call this WebAssembly app inside a sandbox. It's running an executable, it does its magic, returns it, that's it. Let's try that. So let's say just run level 1. That will spin up WAGI. Oh, there is already a sample running. Of course, I prepared for this example, so I forgot to close it. Run it again. And you see, it's running WAGI, and WAGI is now saying, okay, Rainer, I'm listening on port localhost 3000. So what we can now do, let's do that one. We can go into localhost 3000, and I think I called it level 1 ping, right? This level 1 ping will return Pong. And do you know how it worked? It took all this information, ran a separate executable, took the standard output from our executable in WebAssembly, and returned it through HTTP. It works. It works great. It works really, really great. It has a bunch of advantages. No frameworks. Absolutely no frameworks. It's completely platform agnostic. Yes, there are examples out in the internet where you can see such a web server written in C#. You don't need ASP.NET Core anymore, right? Just compile your C# code to WebAssembly, and your framework for building web APIs in the future is console.writeline. And I think Holger is going to show compiling C# code to WebAssembly in his keynote, right? Yes. Okay, very good, very good. So you will see details in C#. I will show you Rust code. Now, of course, we can do more interesting stuff. What I did now is I wrote a little bit of code. Let me show you that. That simply prints out, I will zoom in, that prints out the environment variables, that prints out, no, sorry, that's the arguments, that's the command line arguments. Here we print out the environment variables, and here we copy what we get in standard out, and we copy it to standard in. This is what this code does, right? Let's run this guy here. That is level 2. Here it is. And then let's take a sample request here. This is level 2, send something in. And as you can see, I will change my code a little bit. This is the request that I sent in. And you see the query string, this one, ended up in the command line arguments. The headers, this one, content type, ended up, I have to scroll down a little bit. Where is it? Here. Oh, I did something. It seems that I did something wrong. The content, here it is. HTTP content type, sorry, here it is application JSON. And the standard in becomes the body of the HTTP request. This is how WAGI works. Okay, this is still not containers. It's interesting, it's kind of funny, but can we get something meaningful out of it? Well, yes, we can. What I did now is I have used a language that you might know. It's called handlebars. Handlebars, anybody? Web developers? Okay, I see some hands going up. Let me show you how that looks like. This is a handlebar template. As you can see, handlebar is just HTML. It's kind of HTML template language. For those of you who come from the Razor world, this is like Razor templates, right? The Razor language, but a different language type. It's called handlebars. And what I did is I took the handlebar library and I simply reformat what I get in as command line arguments, as variables, and I take a look into the JSON body and return something. That's not the point. The point is that I'm just now using the handlebar library in Rust, pass in my arguments, render everything in handlebar, and return the string rendered by the handlebar library as text HTML to the client, right? Now use your imagination. You can do anything here. Access a database? Hey, feel free, party on. Access anything else? Absolutely no problem. But there is one problem. We have a big problem. Because this template file is a file. And we are running inside of WebAssembly. And I promised you that WebAssembly is a little bit like containers. So we need to somehow limit WebAssembly so that it can only access this folder, nothing more. Understood? And guess what? You can do that with WAGI and WebAssembly Systems Interface. This is the magic. See? What you do, I will scroll up a little bit so you can see it better, and will remove that one. See? This one. This is like a volume mount in Docker. docker-v host folder colon container folder. This is the host folder. This is the container folder. See it? So inside of my level 3 sample app, here it is, I can simply access here template HBS, and in this case I'm reading the folder from an environment variable. And when running this stuff here, I can set the environment variable to the folder where I'm currently at. Sorry, this is the wrong one. This is the right one. This is the right one. So let's give that a try, okay? Let's run level 3. It's running. Let's take the request, here is level 3, and send something in. Bang. And what we get back is HTML, and I will show you this HTML in the browser. See? This is the formatted HTML that came out of the handlebar syntax. And it worked because we could access this folder. Now what happens if we are not trusting this application anymore? So I go to modules and I will simply here comment out this line. Run it again. I run it again and I will send the request again. Where is it? Here is the request. I will send the request again and boom, doesn't work anymore. Why? Because our app is running inside a WebAssembly sandbox and the WebAssembly has no access to the outer world of the host, just like a volume mount, right? That's wasmtime and WAGI working in the background. Well, this is not just about volumes, but we can do even more. Does anybody play Wordle here? Which one? Wordle, the English one from the New York Times. Okay, very good, because I will now spoil your day because you will see today's solution, today's Wordle solution, right? I hope, if the demo works, okay, if the demo works. So just run level 4 and I will show you what level 4 is. And let's go to request.http and here it is, you see, year, day, month of today, run it and let's see. And the Wordle result for today is, this is the result of today. Do you want to see how that works? I worked on that one with a kid from our Coder Dojo. And he came up, he wanted to hack Wordle, and he found out that all the solutions are simply inside a JavaScript array. All the solutions for all the days in the future and in the past are just a plain text JavaScript array inside of the JavaScript source of Wordle. No server-side logic at all. So what this application does, it's fetching the HTML from New York Times, it's parsing the URL of the JavaScript, it's parsing using regex the JavaScript, looks up the JavaScript arrays, parses them as JSON in Rust, and then simply returns the result using a handlebar template. But the point here, I mean, it's a funny example, and if you want to learn more about Rust, take a look at the code. But the point here is that one, you see? This is beautiful. We can tell our WebAssembly runtime that this sandbox is only allowed to access the NewYorkTimes.com URL, no other domain. That's beautiful, right? We don't have to do anything instead of our code. So it feels a little bit like a container with a firewall in the front that limits what this container can see. But here we have it without containers. And you can embed something like this in your application. Do you see the point? I hope you do. Yes. Good, very good. So breathe in, breathe out. Next step. Why not? Why not sit down and get rid of the separate process? Why not sit down and make a WebAssembly-based component model? Again, a question. I will look in the back again. Anybody old enough to know COM, the component object model? Yeah, you are. Okay. Was it fun? Well, no, it wasn't. But was it useful? Yes, it was. COM essentially made it possible to embed an Excel spreadsheet inside of a Word document. COM made it possible to build reusable components in C++, in C#, and use them from VB. Okay, you might ask, why do I want to use anything from VB? People did at that point in time, right? The point was, there was a component object model, a possibility to use any language on Windows and build a component, and this component could be accessed through any other language supporting COM. That means I have to somehow load the application into my process. I have to be able to translate my, for instance, string. If I'm a C++ program, then string means something for me, into a string that the other programming language understands, like BASIC or C#. Get the idea? So we need a common type system so that components can interact. But what COM didn't support is a sandbox. So if you loaded a component into your app, then this component could do whatever it wanted. And that's not good. Now, why can't we have a modern version of COM built on top of WebAssembly? Imagine a world where you have a type system independent of your programming language. A type system where it is clearly defined what a string is, what an integer is, what a float is, things like that. A system where I can simply run a component inside of my process, and I can super fast do a call into this component. No gRPC, like with containers, no REST API, no GraphQL. Just do a function call, but still get the protection of WebAssemblies. A sandbox for each component. That means that we can micro-modularize, if you want, our applications and run every part of our application in its own sandbox without having to care about language differences and semi-trusted code. We could write a component in Go, another component in Rust, then use C# and do a function call from C# into the Go component or the Rust component, and we simply don't care. That's microservices with container-like security, but inside of a single process, where a function call is no longer an adventure. That would be nice, right? Are we there yet? No. But are we coming to that direction? Yes. Enter Wasm components. Wasm components is the next level where the world, I think, is very much going to. Is it ready for production? Oh, by far not. It's experimental. It's currently in the process of being discussed, being developed. A lot of startups are coming out and doing crazy stuff with this thing. So we are at a very early stage. So if you go out and invest some time here, you might be one of the firsts who take a look at this technology. So let's take a look at an example. I've written an example using the spin framework from Fermyon. Let me show you that. Fermyon spin. Fermyon is a startup application, in the US, and they have created some really awesome things, and they are at the very front of defining WebAssembly components and WebAssembly interface types. This is the type system for this stuff. And they built an application which is called Spin, which is a WebAssembly-based web server, just like WAGI, but you do not need to run a separate process for every HTTP request. So essentially, you are building WebAssembly components, and they can host it in their own process. They can do, I don't know, caching across requests and many, many other things. So this is the next level beyond WAGI. Let me show you how that works. Let me open the spin sample that I created for you. Now, level 1 is the hello world that you saw before, but now not as a separate executable, but now as a spin component. You see, here you have a method. You get a strongly typed HTTP request in. Looks a little bit like ASP.NET Core, right? The request. Or and Express.js stuff. And you return a result that is, again, strongly typed if you want. And in this case, I'm just returning a status code 200 with some string response here. That's the hello world example of Spin. Now this time, we definitely need an SDK. So this is different from WAGI because now we want an SDK because we built a component and we want to have the base types that we need, like response and request and things like that, right? We do no longer have a module.toml, but we have a spin.toml. And here we simply say, where is it? We have a component, and this component here it is. We have a component. This component, give it the ID level 1. It's inside of this Wasm. So we compile the spin component that you saw before into a separate Wasm file. It has a trigger, that is the routing system, and it has a build command. In this case, I'm building everything with Rust. But Spin supports to write one HTTP responder in Rust, the other with Go, and unfortunately, not the third one with C#. You know why? C# does not yet support WebAssembly components. But luckily, Spin can use WAGI behind the scenes. So you can essentially choose between Spin, between WebAssembly components, and WAGI. So if you want to use C#, you simply use what I showed you before, WAGI, and then C# is spinning up a new process whenever an HTTP request comes in. But with Rust and Go, you can already build WebAssembly components. So you see, we are in the very early stages of this project. So let's give it a try, okay? Just run. If I say, probably I've not killed my previous example. Yes, I did. So run it again. So you see, if I run, just run, where was it? Where did I start it? Here. If I run just run, it says spin build. And after the spin build, it says, I can find it here. Here, it says spin up. Pun intended, okay? Spin up, and it starts a web server. And this web server will now relay incoming HTTP request to Wasm components or WAGI, depending what you want. I think you got the point. So let me show you the requests. The first one is this one, and to prove the point, we can call Pong. Now let's go to level 2. Here, level 2. Oh, sorry, I have to make it a little bit different, so let's make it here. Now, the big difference that you see in this second example here is that I can access things like the URI with the query string, or the headers, or the request body with a type system. I have a framework which allows me to access headers and query string and body. I don't need to read the command line arguments. I don't need to read the environment variables. I don't need the body to read the body from standard in. I have really a type system, a framework to build web handlers. And that is Spin. That is the huge difference between WAGI and WebAssembly components and the Spin project. But at the end of the day, we still have the same level of protection. What I did, I translated the handlebar sample, here you see the handlebar sample, from WAGI to Spin. So if you take a look at spin.toml, sorry, here it is, then we still have, see, the file mapping. So the same sandbox principles apply, although we are no longer running these components magically in separate processes. They are really components, but they are hosted components inside a sandbox. And therefore, it's a kind of component sandbox similar to what a container does, but on a completely different abstraction level. Let me prove that this really works. Let's run the requests file for the level 3, this one. And as you can see, here we get back some HTML. See, I can also run this in the browser, and here it doesn't work. Why doesn't it work? Oh yes, Sorry, I can't run this example in the browser because I wrote it so that I need a body here. I didn't find the time to make it bulletproof so it can handle a request without a body, and of course a GET request doesn't have a body. I'm sorry for that, but I think you get the idea. If I make that a little bit larger, then you can see it really works. It is HTML, so it really worked just as promised. Okay, time flies. Time flies. So this was the demo. And so what? Let's do a summary, okay? Will WebAssembly kill containers? No. Containers didn't kill virtual machines. Virtual machines are still a thing, right? If you need strong separation in the cloud, for instance, you might want to consider a virtual machine. It's stronger separated than containers. And exactly on the same level, Wasm will not kill containers. We simply get another possibility on a new, higher level of abstraction. We get sandboxed component models across different languages. It's like containers, but better. Containers with platform-agnostic code. Containers where I don't need gRPC or GraphQL or whatever to communicate between containers, but we simply can call a method. Containers where we can simply add a library and add a sandboxed component support to our application. It's on a different abstraction level, as I told you. It's in a sandbox. Well, I already told you that. Where are the applications? Well, you saw one application today. The Spin framework is a kind of modern microservice system that is no longer a microservice, as in distributed system. Doesn't that sound great for you as developers? You get the advantages of a microservice where you can mix and match different development technologies, where you have a sandbox, but you don't have the drawbacks of containers. You do not need a web API in between your components. Doesn't that sound good? For me, it sounds great. A web server is one application. And these applications are super important because nowadays, many of the so-called serverless cloud environments, take a look at Cloudflare Workers, for instance, they allow you to write a component in WebAssembly, use any language that you like, and then send it, for instance, to Cloudflare, and they can run it in any of their 200 whatever data centers on the edge in a secure way, super fast. Could you take your WebAssembly thing and publish it in a container registry and then pull it like you do with a container, something like this? Definitely you can. In today's talk, I didn't have the time to show you that, but let me give you a quick glimpse here. What you can do is you can use WAGI, for instance, and tell WAGI to read the WebAssembly file, not from a local disk, but get the WebAssembly file from a Docker container registry, like Azure Container Registry. So this is possible, and the large cloud providers, they already do that. So serverless cloud environments, super nice. Semi-trusted components in sandbox to be protected against supply chain attacks will be a huge thing in the future. Nowadays, if we get semi-trusted code, we always think firewalls, right? We need to put it in a separate, whatever, pod or app service or VM or container instance in order to reduce the blast radius. And then we take firewalls and limit the view of this microservice. No longer necessary. Now we can do that with very little overhead inside of our app using components. You can build language agnostic extensibility layers. Do you build business apps? We do that. We build business apps every single day, and our customers want to customize them. They want to upload code which is magically available in our application. Some kind of scripting language. No problem. Take the scripting language, put it on WebAssembly. By the way, Deno does exactly that, and run the JavaScript environment inside of WebAssembly. It's possible, definitely. This is done today. This is not future. So you see, I told you that I asked you, will WebAssembly be the container killer? And you maybe asked yourself, why is he saying that? What has WebAssembly to do with containers? And the goal of the last hour was to give you a clear idea or open some perspectives for you why WebAssembly really has some connections to container technology. Not because it's new containers, but it fulfills some of the same goals as container did, but on a new abstraction level. Containers are a tool for ops, mainly ops people in the DevOps world. Now, WebAssembly components will be a great tool for the dev people in the DevOps world. They will give us similar possibilities, but on a very different abstraction level, as I said already. And with that, I'm in time. I thank you very much for your attention. I hope you liked what you saw and what you heard. And let's open it up for questions if there are some. If you currently don't have questions, you can always approach me in the hallway or send me an email or shoot me a Twitter direct message. I'm more than happy to discuss this topic with you. Thank you very much. Do we have any questions? Thank you. Thank you.